Okay, we are on to 3.3, and this is titled Function Notation. This will be the last section we have before a little quiz here. And we're going to look at our favorite equation we've been looking at the past couple of days. Y equals mx plus b. And again, if we go back to our lecture the other day, 3.2, we know that when something looks like y equals mx plus b, we know that when we look at it graphically, it makes a line. We're going to get heavily into graphing these in the next chapter, but today we're just going to introduce this idea of function notation. And what function notation is something that looks like this. F of x is equal to mx plus b. And when I see this f of x here, you will see this called many different things. You'll see it called f of x, you'll see it called g of x, h of x, k of x, any one of those letters of x. This is just a fancy name for y. It's a fancy name for y. When I see f of x, I'm thinking y. This is my dependent variable. The value of this f of x is going to depend on the value of x that I choose. This is function notation. But the idea behind it is the same. Function notation. First example. Evaluate. I'm going to give you a function, f of x. Remember, it's just a fancy name for y, is negative 4x plus 7. And we want to evaluate this function when x is equal to 2 and x is equal to negative 2. So what we're going to do here is take this x of 2 and this x of negative 2, and two different times I'm going to substitute this in. Where I see an x in this function, I want to replace it for this. And the way we read this is if I take that x and I put it there, and I put it there, this is f of 2. This is saying when I evaluate this function with an x of 2, I'm going to get some sort of output. And I substitute it in right there. The function evaluated at 2, and we read this f of 2. Again, a fancy name for y. F of 2 then, the function evaluated at 2, is negative 4 times 2, which is negative 8, plus 7. So f of 2 is equal to negative 1. The function evaluated at 2 gives me negative 1. When x is 2, my y is negative 1. You are creating ordered pairs. Because this is linear, this is the ordered pair 2, negative 1. And again, we read it. F of 2 is or equals negative 1. The function evaluated at 2 gives me negative 1. I plug 2 in for x, I get a y value of negative 1. It's just a different way of writing what we've already done. For the second one, I do the same thing. The function evaluated at negative 2, when x is negative 2, I want to know what y is, or f of 2 is. I just substitute in negative 2 there. Function evaluated at negative 2 is going to equal positive 8 plus 7. Function evaluated at negative 2 is equal to 15. When x is negative 2, y is 15. I've just created this ordered pair of negative 2, 15. This is my x, this is my y. We take the values that are given, or maybe we will choose these, and we can substitute them in to the function and get out our y values. Here's the next example. Let f of t, we read that f of t, let f of t be the outside temperature. The outside temperature, and we'll say that's in degrees Fahrenheit, T hours. after 6 a.m. On the next example is 2. You are going to be asked to explain the meaning of each statement. So I'm going to give us some statements in function notation. Let f of t be the outside temperature in degrees Fahrenheit t hours after 6 a.m. Explain the meaning. T is going to represent the hours after 6 a.m. The function evaluated at that time is going to give me the temperature outside. So here's my first one. F of 0 is equal to 58. When t is 0, that's the number of hours after 6 a.m. 0 hours after 6 a.m., the temperature is 58 degrees. I'm not going to say 0 hours after 6 a.m. I'm going to say the temp at 6 a.m. is 58 degrees. 0 hours after 6 a.m., the temperature is 58 degrees. The y is 58. The time after 6 a.m. is 0. 0 hours after 6 a.m., which makes it 6 a.m. F of 6 is equal to n. Again, your t is the number of hours after 6 a.m. What's 6 hours after 6 a.m.? Well, that'd be at 12 noon. What's my temperature at 12 noon? N degrees. So the temp at noon, and please don't tell me 6 hours after 6 a.m. I don't want to figure that out. Tell me the time. So the temperature at noon is N degrees Fahrenheit. We're going to say F of 3 is great. Well, let's switch that. Is less than the function evaluated at 9. The temperature 3 hours after 6 a.m. is going to be less than the temperature 9 hours after 6 a.m. So I'm going to say the temp at 9 a.m. is less than the temp at 3 p.m. That's all it's saying. We're just taking what the problem is and we're answering some questions about it. Let's look at this next one. Here's the next example. And we're going to use the same sort of stuff we did up here, but now I'm going to say F of t is the outside temp t hours after 9 a.m. So kind of the exact same thing we're doing in the first one. F of t is going to be the temperature outside t hours after 9 a.m. Here's our statements. F of 4 is equal to 75. I'm going to give them all out because I'd like you to try these on your own. F of m is equal to 70. F of 2 is equal to F of 9. And we'll go letter D. We'll even make one more. We'll say F of 6 is greater than F of 3. So get those down. Take a second. See if you can write it out what we did right up here. Go ahead and pause the video. See if you can get it. Hopefully you got those. Here's what I got. 4 hours after 9 a.m., the temperature is 75 degrees. When x is 4, y is 75. The temp is 75 degrees Fahrenheit 4 hours after 9 a.m. So that'd be at 1 p.m. F of m is equal to 70. The temperature is 70 degrees Fahrenheit, m hours after 9 a.m. 2 is equal to 9. The function evaluated at 2 is equal to the function evaluated at 9. 2 hours after 9 a.m., the temperature is the same as 9 hours after 9 a.m. What's 2 hours after 9 a.m.? Well, it's 11 a.m. The temperature at 11 a.m. is the same as the temp at what time? Well, 9 hours after 9 a.m., 3 would get me till noon, and I've got 6 more at 6 p.m. Last one here. The temp at 3 p.m., that's 6 hours after 9 a.m., is greater than the temperature 3 hours after 9 a.m., which is noon. And there we go. I'm going to flip my paper over. We are going to be also asked in here solving for the independent variable. And hopefully by now we can recall that my independent variable is my x. And with function notation, you are going to be given what that y is. You're going to be given a value. Here's a function. H of x is equal to 2/3 x subtract 5. And I want to find this independent variable when h of x is equal to 7. We'll say -7. This is saying y is equal to -7, and I want to know what value of x gives me that y value of -7. Again, a fancy name for y. So if I looked at this as y equals mx plus b, and I wanted to find x, here's your m, here's your x, this is your b, this y is this h of x. I just simply substitute in what h of x equals, and now I can just go back to equation solving 101 to solve for my independent variable or solve for x. I got to get this x by itself. X is being multiplied by 2/3 and subtracted by 5. I need to reverse those using inverse operations. So I will add 5. -7 plus 5, that's a -2, is equal to 2/3 x, and that's 0. X is being multiplied by 2/3, which means I got to divide by 2/3, and dividing by a fraction, multiply by the reciprocal. This is very handy. That's going to tell me what x equals. Remember, when I multiply by the reciprocal, my product is 1. 3/2, or 1.5 times -2, well, it just leaves me with -1. 3 times -1 is -3. And what you have here is when x is equal to -3, h of x is equal to -7. So really what you have is when this function is evaluated at -3, I get a y of -7. And you could certainly check that, couldn't you? Don't you have an ordered pair of 3, -3? negative 7. And if I asked, is this a solution? Well, you'd come right back to this. Remember, this is a fancy word for y. You would check that by putting in negative 7 is equal to 2/3 times negative 3 subtract 5. Well, that's going to be negative 7 is equal to negative 2 minus 5. Negative 7 does equal negative 7. It works, and it should work, because I found out what x was when y was negative 7. Here's the next example. We'll say j of x is equal to negative 4/5 x plus 7. And this time we will say j of x is equal to negative 5. And again, you are going to do the exact same thing. You want to know the value of x that gives you a y of negative 5. You want to know if my output is negative 5, what input did I use to get negative 5 using this function? If I substitute that right in, I'll be able to tell what that value of x is. Negative 5 then is equal to negative 4/5 times x plus 7. I would subtract 7. Negative 12 is equal to negative 4/5 x. I need to divide by negative 4/5, which means I need to multiply by the reciprocal of negative 4/5, which is negative 5/4. What I do to one side, I must do to the other. How convenient. That's going to leave me with a positive x. 4 goes into negative 12, negative 3 times. Negative 5 times negative 3 gives me an x of 15. So the function evaluated at 15, when x is 15, it gives me a y of negative 5. You have this ordered pair here, an x of 15 and a y of negative 5. And you could certainly plug that back in, this for x, this for j of x, and you should get a true statement. I'm going to do that out real quick. X is 15, y is negative 5. Does negative 5 equal negative 4/5 times 15 plus 7? Well, that would be 3. Negative 5 is equal to negative 12 plus 7. Look at that. It checks. I know that's an ordered pair. I know that's a solution. And I can go ahead and write it. The last thing we need to look at today is graphing. And I'll put some graph paper in there, but we are going to want to use some graph paper because it's nice and easy to organize. Graphing a linear function. Graphing a linear function. Here's my function. F of x is equal to 2x plus 5. You are going to be asked to graph that. Y equals 2x plus 5. If this was y equals 2x plus 5, hopefully you'd be able to tell me, because this looks like y equals mx plus b, this is a linear function. It's going to make a line and we're going to graph it. There's some steps we take to do this. For right now, we're going to start out by make an input, output table. We're going to make a table. From that table, our second step is to make and plot the ordered pairs. And the third thing you are going to do is draw the line. And we'll take this step by step. Step by step. So here's my XY table. This is what we've done all along. I'll put my function here. F of x or my y is equal to 2x plus 5. You're going to be asked to choose values for your input and output. We can choose these values for x, and I can simply substitute them in for where I see an x here and get out values for y's. I will then have ordered pairs that'll lie right here that I can then plot. What's an easy one to pick? I always like picking 0, because if I take 0 and plug it in, that just leaves me with a y of 5. 2 times 0 plus 5. Remember back from yesterday too, we want a constant rate of change. What are some nice easy values to pick? I'm going to pick -2, -1, 1 and 2. And I didn't just choose those. I chose some values of x that would be negative, and I chose some values of x that would be positive, because if I graph this, here's where x is negative over here, here's where x is positive over here. And if I choose values of x that are negative and positive, whether the line falls or rises, I'm going to have a good look at what happens on either side of the origin. Constant rate of change again, because this rate of change is increasing by 1s, I would expect to see a pattern down here. I don't know what that pattern is yet, but I bet I can figure it out. If I plug in -2, f of -2 is going to equal 2 times -2 plus 5. The function evaluated at -2 is going to give me 2 times -2, which is -4 plus 5. Function evaluated at -2 then gives me a y of 1. You have an xy ordered pair of -2 and 1. You could plug in -1. Some of you might be able to see the pattern already. It's got to be going up by the same. What's halfway in between 1 and 5? Well, 1 plus 5 is 6. Halfway in between would be 6 divided by 2. This should make this 3. And I can certainly plug this in and check it. 2 times -1 is -2 plus 5 indeed gives me 3. This is going up by 2's. And you can certainly plug in 1. 2 plus 5, 7. 4 plus 5, 9. Constant rate of change. You need to make an XY table or coordinate plane now and get these graphed. So we're going to make simple XY coordinate planes for each one. And I made my coordinate plane just like this, heavily more weighted in this positive in this y direction, because I can see from my ordered pairs right here that I'm going to have to go up to 9 on the y-axis. I've got these ordered pairs. You've got the ordered pairs. I'm going to draw those right here. -2, 1. -1, 3. 0, 5. 1, 7, and 2, 9. Do you have to write these out? No, you can certainly pull these right here, but just know this is x and this is y. I'm going to plot these. -2, 1 to the left. Let's scale this. I'll go by 1s. I'll make this -1, -2, -3, and I'll go up 2, 5, 6, 7, 8, 9, and 10. -2, 1, right there. -1, 3, right there. 0, 5, right there. And you can see you are getting a constant rate of change. These are all lining up. You are going up 2 and over 1, up 2 and over 1. That is the ordered pair 1, 7. From there, I go up 2 over 1. How can I do that? Because the rate of change is constant. 2, 9 is that point. They line up in a nice straight line. I'm going to take care to connect those dots. And I'm going to stick some arrows on the end of my line to let everybody know that that line continues on to infinity from here on out. Couple of things to look at. There's a couple in your problems off of your worksheet where, let's say, y is equal to 2/5 x plus 3, or I could say f of x is equal to 2/5 x plus 3. And you're going to be asked to make a table. When you make a table with something that has a fraction in front of it, I would absolutely choose values of x that make this easy to plug in. 0 is still a nice easy one to choose, because if I plug in 0, I know it's 3. I'm going to choose -10, -5, 5, and 10. And why did I choose those numbers? Because if I chose a value of -1 and -2, I'm going to take that -1 and multiply it by 2/5. That's going to be a -2/5 plus 3. And I can certainly make that into, 2 3/5. But 2 3/5 is hard to graph. This is still has the same rate of change. I'm increasing by 5, so I should see a pattern right here. If I take 2/5 times -10 plus 3, that's going to give me a -2. I'm going to have -4 plus 3. Y then is going to be equal to -1. If I plug in -5, 2/5 times -5 plus 3, that's -2 plus 3. That gives me a +1. And I can see right here, I'm going up by 2's. That's going to be 3. That's going to be 5. That's going to be 7. Those are what you need to plot. The hint is, when you have this fraction out front, choose values that are still have a constant rate of change but are divisible by this denominator here. So if I had a 1/3 x, I would choose x's that are divisible by 3. I might choose -6, -3, 0, 3, and 6. If I had 1/2 x, I might choose -4, -2, 0, 4, and 2. Reason being is when I divide those x's by that number, you're going to get an integer and not a fraction. Give those problems a whirl. We'll make a Google Meet and we'll talk about it.